Okay, so we're supposed to find the angle to the nearest tenth of a degree between 3, the vector 2, 3, and the vector 1, 5. We had to remember the formula. Cosine theta equals, remember this dot product formula, so that's what reminded me, is that you can make a note card and put this right on there. And our dot product theorem says that cosine theta equals the dot product of A times B, all over that magnitude A times the magnitude of B. So that just means I need to find my magnitudes, and then I'm going to use the dot product. Okay, so let's go ahead and find our magnitudes first. A lot of times we let R stand for our magnitudes, so we're going to say R1 is going to be for that vector 2, 3. This is going to be A squared plus B squared, take the square root. Well, our A for 2, 3 is 2, so it's 2 squared plus 3 squared. So our magnitude is going to equal 4 plus 9 square root, so you square root of 13. My magnitude of vector 1, 5, I'm going to let R2 stand for that magnitude, is the same thing. It's the square root of A squared plus B squared. Our A is going to be 1. Our B is going to be 5. And that's going to equal the square root of 25 plus 1, which would be the square root of 26. I don't know, that's so scary. Okay. So those are our magnitudes. So that's magnitude A and magnitude B. That's what's on our denominator. That's what those absolute value bars are showing me. It's magnitudes. Okay, so we have both of those. On top, so let's go ahead and rewrite our things. We have cosine of theta is going to equal the dot product of our two vectors. Well, that's going to be 2, 3, dot product with 1, 5. All over our two magnitudes multiplied, so it'd be square root of 13 times the square root of 13. Let's just go right with it so we have room. Dot product is basically, I just multiply my two A values, multiply my two B values, and add that together. So that's going to be 2 times 1 plus 3 times 5. I'm not going to simplify that bottom. Oh, I have 2 square root of 13, don't I? It should have been square root of 13 times the square root of 26. So one of these guys should have been 26. Okay, well, 2 times 1 is 2 plus 3 times 5. So we have 17 on top. I need to take the cosine inverse to get theta by itself. So it's going to be theta equals cosine inverse of, like I said, on top we're going to have 17. Over, I'll still have the square root of 13 times the square root of 26. Well, that's just going to equal about 22.4 degrees. All right, so most of this is just plug and chug. It's just whether you know what this is and what everything stands for. All right, so the top was dot product, and the bottom was magnitudes. In your notes, you should have that written down, that this is dot product, and these are magnitudes on bottom. So just remember, magnitude and length is always going to be this square root of A squared plus B squared. So whenever you're looking for a length in any one of these sections, it's always going to be this formula. And we're going to see that repeats again today. But before we get to today's assignment, were there any questions on the homework minus 57? Because the book answer key just decided to take a left turn and solve it a completely random way. You could have solved it the way you solved all of them, and it should have came out to the right answer. But the book just decided to use the cosine sum identities for whatever reason. We aren't going to do that. Okay, so if you're confused by how the book does, don't worry about 57. That was just should have been just a normal problem. Have you seen other questions? Almost really? Yeah.
How would, just for the bell work, how would you put that in your calculator?
How would I put that in my calculator? Yeah. I would hit the cosine inverse button, right, which opens parentheses. Yeah. and then I would type 17, and I would hit divided by, and then just to make sure everything happens right, I would open parentheses, put square root of 13, square root of 26, close parentheses, close parentheses. Okay? That way you know what's in the denominator. Otherwise it's going to do 17 divided by square root of 13 multiplied by square root of 26. So it probably didn't come out the first time, right?
Right.
So make sure your denominator is always in parentheses. Did that come out right then?
Yeah.
Oh, good, good. All right, right.
51.
51? Okay, let's go ahead and bring that guy up. Okay, so we're supposed to find z sub 1, z sub 2, and z sub 1 divided by z sub 2 for each pair of complex numbers. Did you have problems finding the trig form or just the multiplication and division?
The trig form.
Do you know which one?
Z1.
Z1? Okay, so let's look at the trig form of Z1. So we'll put Z1 in trig form. So the first thing I'm going to do is I'm going to find my R value, right? Because we have R times cosine theta plus I sine theta. So we need an R and we need a theta. So let's go ahead and find R first because that's the easiest one. And that's just going to equal the square root of our A value. Well, they're both 4, but our A value is actually our first 4. So that's 4 squared plus 4 squared. So R is going to equal the square root of 32, which you could simplify, but we're going to plug into our calculator anyway, so why not? I think we could just leave it like that. No, it's going to be an R value. So we could simplify it if we wanted to, because that's going to equal 4 times 8. So you could rewrite this as, ooh, we can go further than that. What am I doing? What am I doing? 16 goes into that bad boy. We can go 16 times 2, which equals 4 times square root of 2. So if you looked in the book, it probably has 4 square root of 2 as your R value. Okay, to get my angle, let's go back, because this has been tricky for some people. Let's go back to just drawing a picture, because you should always have some kind of picture or some idea where this is in your head. So we're going to go ahead and draw this, and that's going to be 4, 1, 2, 3, 4, up 4, 1, 2, 3, 4. I'll put a point there. So our theta that I'm looking for is actually this angle. That angle there. I don't have a ton of room, that's why I'm writing it out there. So our theta is inside of here. But that's a right triangle. That goes 4 and 4. So to find that angle, we could just do the tangent of theta equals opposite over adjacent, which would be 4 over 4. Either you know this offhand or you don't. We can do theta equals the tan inverse of 1, and that gives you your theta. Okay, so you can use your unit circle to get that one, or you can actually plug that in your calculator. Okay? I always like drawing the picture. Always draw the picture, because the other way we did it yesterday, or the other day, was we said A equals R times cosine theta. We plugged in the R and the A, and we solved for it. Sometimes that doesn't solve the angle I wanted to. Sometimes it will solve the complementary angle, and we have to recognize that. And the only way to recognize that is to draw a picture. Okay, but does that make sense? I got everything? Okay. So this always works. Draw a picture, tangent. It takes a little bit more work. Honestly, sometimes you can picture these in your head, and on the test I'll give you more room so you have room to draw a picture. Okay, but it's always good to at least draw a picture or mentally picture where that point is and what it makes. Okay, other questions? Will that fully answer your question? Okay, other questions? Go once, twice, tres, cuatros, cincos, seises? Okay, now let's get into today's lesson. It won't take long. Even though it sounds complicated, it's not so bad. We're going to learn a whole new coordinate plane. We already learned one whole new one. This is going to be the second whole new one we're going to learn in one section. We learned the complex plane, right? Was the complex plane that hard to use?
Yes.
No, it was just, yes. Besides Matthew, it shouldn't be that hard because it's just, we had to plot our real, our imaginary, and that told us the point. The same thing's going to happen today. We're going to talk about, ooh, I'm missing a whole slide. I forgot about that. We'll just jump right to the problems.
Okay.
You don't need any explanation, do you?
No.
Okay, so we're going to talk about the polar coordinate plane. Like I was starting out, our rectangular coordinate system, we needed 2 bits of information to plot a point. We needed our horizontal and our vertical, which we used our x and y values. With our complex ones, we used real and imaginary. So those were our 2 axes. The polar coordinate system also requires 2 bits of information. It requires a distance, right? Our distance, which we can also call magnitude or absolute value. So we need a distance and we need an angle. So how this is going to work is how this point's going to go is I'm going to find the distance and I'm going to rotate it with the angle, and that's going to be my point. So this line actually isn't there, it's just going to be that point. It sounds more complicated than it actually is, you'll see in just a second. I just have to show this diagram to put a little bit of information down. So when we do x, y coordinate, we call that very center point, 0, 0, the origin. With polar coordinate plane, we call this point the pole. That is the pole. In other words, our pole, let's put a little, pole is the same thing as origin. And then rather than calling this the x-axis, we call this the polar axis. So we really only have one axis that we can see, but we actually have one once you see this in service. All right, so the 2 things we need to recognize is I need to know distance and I need to know angle, which we've needed to know all the time for vectors and stuff. And we put in stuff in trig form. Distance, angle, distance, angle, distance, angle. All right, so let's just do an example. It makes it easier once you see something. So we're going to plot the point 2, 5 pi over 6. So that 2 is my r value, which is my distance. So that's my r value. And obviously 5 pi over 6 is going to be our angle or our theta. So how this is going to work. This axis and all these little tick marks are our length of our point. So our length right now is 2. So what we're going to do is on what was traditionally our x-axis, but now is our polar axis, we're going to draw a line out 2. So 1, 2. See how it went through 2 tick marks? 1, and then our second tick mark. So that is now out a distance of 2. Let me see what we're doing with the next one. There. Okay, so this is out a distance of 2. Now what we're going to do is we're going to rotate that point 5 pi over 6 degrees. And so we just have to find 5 pi over 6. It's right here. So what we're going to do is we're going to rotate this point along that second tick mark until I get to 5 pi over 6. And my point is going to end up right there. Excuse me. So we're going to kind of tick mark this around. This line doesn't actually exist. And we get to 5 pi over 6. So tick mark, and we get to 5 pi over 6. So the only thing that actually exists right here is that point. And that point right there is 2, 5 pi over 6. So we go this direction, 5 pi over 6 units. And we're always going to go counterclockwise. Our next one says that we have -3 in pi. Now I'm going to do the same thing. I'm going to start on the polar axis, except I'm going to go over 3. 1, 2, 3 marks. So let me change the color of my pencil. Let's change to green. So like I said, I'm going to count over 3 marks. 1, 2, 3, and I'm going to put a point right there. So that distance is 3. Well, let's call it -3. Is -3. All right, now it says I have to go pi distance away. So we are no longer concerned with this being pi. I have to travel pi units, or 180 degrees. So that's going to go here. So depending on where you start is going to depend on when you start counting. So this one I have to go all the way around 180 degrees. Or in other words, I'm going around pi units. And this is going to be the point, -3 pi. So you have to start to kind of figure out where you're going to end. And that's all predicated on whether it's a positive or a negative distance. If it's positive, we're always going to start here and we can use our regular unit circle. If it's negative, you have to kind of reverse what you're doing, okay? So if I needed to go -3, and let's say I had to go pi over 6. Pi over 6 here would be 2 tick marks, so I'd go at -3 and I'd go 2 tick marks and be pi over 6. In other words, we can go straight across and that'd be pi over 6. All right, so we kind of flip everything when we got a negative. All right, let's do it 2 more times. Our next one is -1, 450 degrees. What I'm going to notice there is I have to go all the way around 1 full revolution and a little bit further. I don't like going around a million times. So what I'm going to do is I'm going to say, hey, rather than 450, let's do 450 minus that extra revolution of 360, which is just going to give us 90 degrees. Once again, we're going -1, so I'm just going to count out -1 distance. And I got my point there. If you can see, it's way down there. Maybe I'll make it a little bigger. It's right there. We're going to go around 90 degrees. So that's going to go in that direction. And my point is going to be right here. That is going to be the point, -1, 450 degrees. So something weird about that is also the point -1, 90 degrees. It also matters which direction this is. They're almost always positive. It's almost always like 90 degrees. But if it was -90, you would know you have to go the opposite direction. Okay, so be very concerned about, or be very aware of negative numbers. All right, the last one is 2, 3 pi over 4. Let's do this guy in red. We're going to go out 2. And then we're going to wrap around 3 pi over 4 radians. So we're going to go dun, 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 dun. Put our point right there. And this is now the point 2, 3 pi over 4. 2 bits of information. I got areas for 2 bits of information. Just remember your starting is your length, and then you just got to figure out whether it's degree or radians and how far to go. That's the hardest part, is figuring out how far to go. Any questions on those? No? I can't make them too much more difficult than that. It really is just plotting points. Okay? Please let me know tomorrow if something doesn't make sense, we can do it again. Because we're kind of skimming over the polar axis. I mean, could be taught. I could do an entire chapter on just this one little section. In fact, I could do more. I could do a whole unit, just like you did with x and y values. You can do the same thing with polar. It's just we have one little section to do it in. Yeah.
So then on the homework, what points do you want us to plot?
Yeah, that's in your book. It didn't.
Okay,
It didn't
okay.
print off. I guess it was really light, and the printer just cut it off. So what Peyton's asking is on your homework. You have a whole bunch of blank spots. You're going to have to use your book to get those points. And your book is online in case your book is being used as a doorstop somewhere. All right. So you have to crack that baby open. Okay. So we're going to convert polar to rectangular numbers. So I want to go from polar r theta to rectangular, which is x, y coordinates. Now you guys have to pay attention a lot to this one because it's going to be a brand new formula you haven't seen at all. You haven't seen it at all throughout this entire chapter in every single section, okay? So we're going to solve for x and y values. So if I had to do that, I would do, hey, cosine, let's move to black. Do you see what it's going to be? Is that one? Okay. Okay. So we're going to do cosine of theta equals adjacent over our length r. Well, if I multiply both sides by r, I'm going to come up with x equals r times cosine of theta, a brand new equation we haven't seen at all 100 times so far. What was that? Because it's so brand new. Who wants to take a stab at what y equals without even doing the work? Yeah.
No, y equals r sine theta?
Oh, that's quite a guess, and you are correct. You are absolutely correct. And let me just put up here again that work for it. Sine of theta is going to equal y over r, but that means my equation is y equals r times sine of theta. All that happened was A and B took a day off, and they changed to x and y, because we're talking about the x, y coordinates. We've done this thing 3 times in 3 different sections. By now we should kind of recognize that, hey, if I'm on a test and I'm stumped about changing from something with length and degrees to something that doesn't, we should automatically default to r times cosine of theta and r times sine of theta. And in fact, this ordered pair xy is the same thing as the ordered pair a, b. We just use a and b to stand for things that were in vectors. X, y is on the norm. So we should know these. Whew, brand new problem here. Convert 210 degrees to rectangular coordinates. So we're just going to say x equals r. Well, our r value is that 6. Our theta value obviously must be that 210 degrees. So x is going to equal 6 times cosine of 210 degrees. And our y is going to equal 6 times sine of 210 degrees. We don't have to go clickety-clickety-click, because cosine 210 is actually on our unit circle. It is actually 6 times negative square root of 3 over 2, so x is just going to equal negative 3 square root of 3. 210 degrees, that's in the 3rd quadrant, so that must mean sine is also negative. And if we remember back, square root of 3 over 2 always pairs nicely with a nice 1 over 2. So that must mean that our y equals 6 times a negative 1/2. So y is going to equal a negative 3. So our point is negative 3 square root of 3. So if we're ever asked to put anything in rectangular form, it's always going to be this equation. No matter what you're talking about, rectangular form, to get back to it is always going to be this equation. You guys ready for some more mind-blowing action here? Oof. We need to convert from rectangular to polar. That means I have x and y value just like I would an a. So that means I need to get an r value, kind of like our magnitude, and I need to get a theta, which is our directional angle. R, hold your horses, because it's going to be brand new as well, is going to equal, does anyone have a guess what r is going to equal? My hint is there's a square root involved in it. And we used it a billion times. We used it in the bell work. Callie?
The square root of x squared plus y squared.
And if you say a squared, you know what you're talking about. Yeah, I'm just going to put an x squared plus y squared. If you remember that it's a squared plus b squared, you're not going to get it wrong. You just have to know that x is actually your a, right? It's your first value in the ordered pair. All right, the second step is just to get our theta. And in this one, we're going to go back to just drawing a triangle because I think it's a little more of an accurate way. So to find theta, we're going to use our tan inverse. Because we're going to draw a triangle, which we're going to know are adjacent and are opposite, and so we're going to use tan inverse to solve for our theta. And this is the harder of the two things, because this should be easy by now. R equals a squared plus b squared, take that square root. Okay, so let's go ahead and do that. Our first step is to find our R value. So our R value is going to equal the square root of x squared plus our y squared. So that's negative 3 squared plus 6 squared. Well, that's just going to equal the square root of 9 plus 36, which is the square root of 45. Done with half the problem. Whew. Second part, I want to get my theta. Well, let's just do a quick drawing of where we are. So if I do a quick drawing off to the side, and I have the point negative 3, 6. Negative 3, 1, 2, 3, 6, 1, 2, 3, 4, 5, 6. I put my point up there. So that's my point, negative 3, 6. I want us to note that we can make two possible triangles with this. I'm going to draw one, and then I'm actually going to solve the other one. So we could go that direction, find our theta, and just recognize that the angle I'm actually looking for is this full angle. That's my theta. So I could find this angle, add it to 90, and I have my answer. The other way we can do it, and I'm just going to solve it this way because it's the last time I'm going to write it, is I can find my theta by finding this angle first. And I'm going to realize that, well, I don't want this angle, I want this opposite, so it would be 180 minus this will give me my full thing. So that's what drawing a picture lets you do. It lets you use some common sense to figure out what to solve for. So our distance is going to be negative 3. Our height of this triangle is 6. And I'm going to go ahead and call this angle alpha. I'll call it angle alpha so we don't have two thetas up there. All right, so the tangent of alpha is going to equal opposite over adjacent, because TOA, opposite over adjacent, which is 6 over our negative 3. Well, I don't care what tangent alpha equals. I want to know what alpha equals. So we're going to go alpha equals tan inverse of that negative 6 divided by 3, which is just going to be negative 2. All right, here's the problem with this. This is going to equal a negative 63.4 degrees. Does it make sense that my angle is negative?
Yes.
Kind of. But what do I know? What do I need to know to do? Do I want to do 180 minus a negative 63.4 and come up with 100 or 240? No, you should tell yourself that's wrong. I'm just going to go ahead and subtract 63.4 from 180. So our actual theta is going to equal 180 minus our 63.4 degrees, make degrees, degrees, and that's going to equal 116.6 degrees. So in polar coordinates, yeah, did I miss something?
Isn't it negative?
I just went over that. Would it make sense? We have to be smarter than the problem, all right, that our calculator shoots out. Right? Would it make sense if I did 180 minus a negative 63.4? Then I would have 243.4 degrees. Is this a 243.4 degree angle? No, that's why I kept telling us in this point that as soon as you come to this, you have to say you can't have a negative. Can't be negative. It can't be negative, so we have to use the positive version of it. So it's 180 minus the positive version of it. All right? Does that make sense? The other way you can keep from making that mistake is you could also make this positive 3 and you would have came up with a positive 63.4 as is, if you made this positive to begin with. Just remember, at the end of when you're finding these, it has to be a positive number. Whether you're finding the complete one, or you're finding just a chunk of it, it has to be positive because we're actually dealing with a real-life triangle, or we're trying to deal with a real-life triangle. Okay, so that means our polar coordinates are going to be, my r value is square root of 45. My theta is 116.6 degrees. And just a quick reminder, Peyton already brought it up, but I'm going to bring it up again. You have no values in here. You're going to have to use your book to plug in those values. Okay? The book is online, so if you have a computer, you could just do that as well. All right, we have, like 8-9 minutes, so we can go ahead and get started on the homework.